Given an array of numbers, find the maximum sum of any contiguous subarray of the array. So the keywords are, we need to return the maximum sum of what? Contiguous subarray. Contiguous meaning they are um, continuously, like there's no break in the subarray. So you can say that this is a contiguous subarray. This is a contiguous subarray. But if I get this one and this one, it's not going to be a contiguous subarray. It will be a non-contiguous subarray. So think of it like a straight line. Now we are given with these elements in one list or array, and we have 34, negative 50, 42, 14, negative 5, and 86. And in this case, we are expected to return the maximum sum of 135, and it should take the elements 42, 14, negative 5, and 86, which is this. It's contiguous. Okay. Uh, don't mind this one for now. It's just an extra constraint. Let's just try to solve this one. So it says to solve it in ON time, meaning linear time. But let's first talk about doing this in the brute force approach with the ON squared time. Okay. Let me put this away so it won't distract you. So at first you would have a current sum that would track the sum that you currently have, and then you wanna start with assigning the first array element to current sum. This is just to avoid the fence post, the index out of range, out of bounds error, and because we already initialize current sum, let's also initialize our max sum with the first element. And we'll go ahead and create a for loop to iterate over the array, and another for loop as your second pointer. So it would look like when I grab this, it means that I would first start at here. We grab that. And in the first loop of this one is, let's add 34 and negative 50, and that will be negative 16. And then let's get the max. Is the max sum better than the current sum? Our current max sum is again 34. So let's go ahead, and this is the current sum. Just want to visualize it for you guys. And this is the max sum. Again, just to know that it started with 34, and the max sum started with 34 as well. And the next thing that we got is we added the second element. That's why we got the negative 16. And now is the max sum. Again, the previous one is 34. Is it better than or greater than negative 16? No, so we still choose the 34 as our max sum. And then we keep iterating that until the end of the j in range. So it goes towards to the end of the list or array. So this can keep continuing with negative 16 plus 42, which is this is 6. It's 26. Positive 26. Still 34. And then this is 40, and this is still changes to 40 now because that's bigger, and we'll get the negative 35, and this one becomes 40 still, stays at 40, and we have 86, and that becomes, this is 1, this is 5, 51, and then we got 51. This is just for the first loop. Okay, the second loop would be the current sum, and in that current sum we would have the 34, and then in the max sum, nope, this one is for the second 4-second loop in the I would say. And now you would have it started with 0, right? And now I would start with I plus j, which is 1 plus 1, so it starts at here, get negative 50. Compare that, we see the previous one is still better, which is 51. Then we go to the next, which is 8, and now 51 is still better. We get the next one, which is 8 plus 14 is 22, still 51. 22 plus negative 5 is going to be 17, 51. And then 17 plus 86 would be 103. 103 is way better. And that's your second loop in I. How about your third loop in I? Current sum starts with I, this one. 1 plus, we're now at 2. Oh, sorry, this is going to be, start at, it's more clear, start at element at third element. Okay, we start at 42, max sum, 103 is better. Next we have 156, 103 still better. And we have 56 plus negative 5, 51, 103 still better. And 51 plus 86 is now, I could say 137. And this becomes 137. And now let's see the fourth loop. Fourth loop, start at fourth element, just to make that very clear. Current sum is start at 14. Again, we keep initializing it to 0, that's why we get the start of the element as the current sum. This is still 137. 14 plus negative 5, we have now 9, and 137 is still better. And then now we have 86 plus 9, that will be 95, and still get the 137. And now we return 137. So that seems like a lot of work. But if we now move on to dynamic programming, we can now make this in linear time, and they call this the sliding window as well. So what happens here is basically you change your starting point every time if the element that you're checking is better than the current running sum, meaning the aggregate of the previous ones. And now you start off with that. So there's two things. It's either do you keep adding the elements and making your current sum grow, or do you want to start with that new element and check if you can grow that starting point of that element. Well, again, let's just visualize this, and we start with, again, the current sum, max sum, and copy the top for the visualization. Let's put that here and remove that. And again, because we initialize, we start off with the current sum 34 and the max sum of 34. Okay, the first current sum, we add now the second element because we started our R of I, which is 1, and if we add that up, that's gonna be negative 16. and this is the element that we're looking for. I think I should paste that. Should I paste that or not? Maybe not. And then is negative 16. Now we go to this one. Is array of I, which is a negative 50, is it greater than the current sum, which is negative 16? The answer is no. So it means that we still can grow the number of elements that we can add to the current sum instead of starting in a new element. Okay? In short, we did not do anything. We're just going to keep aggregating for the next loop. And this one is basically is current sum greater than max sum, which is no. So we stick with 34 still. The second loop now, current sum, negative 16 plus r of I, which is 42. That now gives us a 26. And now we ask, is array of I is 42. Is it greater than current sum? Yes, it is. So now you'll see that you now start at 42. Interesting, right? And now, is current sum greater than max sum? Yes, it is. Let's update 42. So what happened here is the first iteration was this one, and the third iteration checks for this one. It says, oops, the current sum, this one is bigger than the sum of these three elements basically is less than the element of element value 42. So we start now at here. That's why we're now at here. And next iteration, current sum is now 42 plus r of I. R of I is now 14. We start with 60. No, oops, that's 56. And then we try to evaluate that again. Is 42, is 14, we're 14 right now. Is it greater than the current sum of 56? So now it's comparing, is 14 greater than this two, the sum of these two? Nope. So we can continue growing. And we'll just check, is this one greater than this one? Yes. Now we can update the max sum. Next iteration, current sum is 56. We add the second element. The next element is now negative 5. Okay, it becomes 51. Now we ask again, is negative 5, for this one, is negative 5 greater than the current sum, which is 51, which is no. It means that we can still keep adding elements instead of starting off the new one. So this means that we still can continue this contiguous subarray, okay, or elements. And now is 51 greater than 56? No, so we update the max sum. Let's loop again. Now 51 plus 86, we have now 137. And in that 137, we evaluate if the 86 is greater than current sum, which is no. That's why we don't need to really reassign. And then, but if is current sum greater than max sum? Yes. So we update. And now we should have a return of 137. Okay. Thank you.